Hi and welcome to AI Sciences. In this video, we are going to see that how we can count the open fingers using OpenCV. I'm your instructor Muhammad Ahmad from AI Sciences, and in this video, we are going to see that how we can use OpenCV to get the video, use media pipe to extract the landmarks present on the hand, and then we will discuss the complete flow, that how we are going to extract all that information and how we are going to count that what are the open numbers of the finger, and then eventually we will do some hands-on with that. If you are new to our channel, then just a brief introduction of the AI Sciences. At the platform of AI Sciences, we are providing a lot of services regarding artificial intelligence, data science, including courses, including consultancies and on-demand software development, product development and whatnot. If you are interested in any of this, then do visit the links present in the description. So let's just begin. So the first thing that we actually want to explore is the OpenCV, and OpenCV is nothing more. We will just use that OpenCV library for getting the input from the video, and then all the work will be done by media pipe. So OpenCV is just will sort of lay the foundation or provide us the input. This thing, media pipe, is basically the main chunk or the main handler of this entire theme. Now what this media pipe library is, that media pipe library is basically built and maintained by Google, and over here there are number of postures, number of hand detection, number of face detection models pre-prepared. So we just need to import them and we are good to go. So we will just import the media pipe library and we will ask it to provide the hand module, and we just need to provide the input to it, and it will provide us with all the landmarks and all the information available on the hand. So if you actually want to give it a go, give it a read, I would highly recommend you to just open this documentation and explore this. There is much more into it, and it's actually pretty good. So the thing that we want to notice at this point is this, that when we will show or when we will provide hand image to or hand video to this media pipe library, it will extract these landmarks present on the hand. So it will extract that, okay, this is the wrist, this is the thumb, this is the index finger, this is the middle finger, this is the third one, this is the last one, and all the points available on all these fingers. Now after getting all these points, we will see when we will start doing hands-on with that how we are going to extract this information, but it's quite simple. So after getting all this information, the next thing would be we have to devise a way with which we can simply check that if this index finger top or this index finger tip is actually below this point. So if the hand is open, then we can expect that this index finger tip must be above this point. Same goes for all the fingers, that if this 12 is above this 10 point, so that means that the middle finger is up. If this 14 and 16, if this 16 is above 14, so that means that this finger is open, otherwise this finger is closed. Same is for this one. If 20 is above 18, so that means that this finger is particularly open, and if it is below that, so that means that this finger is closed. Now there is just a single exception or an extra case that we have to manage, that if we are talking about thumb, so we cannot say that if 4 is below 2, so that means that this thumb is basically open or closed. So the basic idea is, if I may show you this hand, that at this point, just notice that when it wants the hand to be closed, the thumb to be closed, it is just moving it inside. It's not moving it downward. So it's all coming all the way from here to this point. It's not going from here to this point. So we just have to put an exemption over here and write a single liner if statement that will check that if this point is actually to the right of this, and vice versa for the left hand as well. I'm not going to diversify and make things complex by going all the way to left and right and all of it. It's quite simple. If you get the idea of how you can do it on the right hand, then you can easily replicate it on the left hand as well. So I guess that this is pretty much it from the theory section. Now let's just go for the hands-on. For the hands-on, I'm using this PyCharm IDE. You can go for any editor, but personally I prefer working with the PyCharm IDE because of its diverse nature and its very good intelligence, and it's quite helpful when you are working with Python. Now, first thing that we have to do, we have to make some imports. So we will import OpenCV and we will import the media pipe. For you, when you will import it, you will get the exception, or the section will be underlined that no media pipe found or not CV2 found. You just need to click on it, go for Alt Enter, and it, instead of optimize imports, you will be getting the command over here that install this library, and same install this library. If you are not working on the PyCharm, you just need to go for the terminal, and here you will provide it with pip install python OpenCV. That's it. And for the media pipe, it's media pipe. And when you will hit on it, it will simply import it if you are not using the PyCharm IDE. So these are the imports, and now first thing that we have to do is to capture a video. So when I'm referring to the video and I'm referring to the images, they are kind of equivalent in context of OpenCV, because if we are talking for a video, we don't actually process a video. A video basically comprises of frames and images, and when we are talking about a video, we are indirectly talking about all the frames that are present inside that video, or all the images that are present inside this video, and all the images comprises together to create a video. So on the other hand, if we are talking about image, we are directly talking about image. So it's interchangeable, and we can use them interchangeably in this context. Now what we have to do, we have to actually get the video, and then we just need to iterate on it. So we will declare a variable capture, go for CV2, ask for the video capture, and here if you provide the 0, what it will do, it will, if we provide the 0 here, it will open your front webcam and it will start taking input from there. If you don't want to do that, you will get this fingers.mp4. You can get the link in the description, and it will simply provide you with the hands, and the hand will be just closing the fingers and opening it. But still, if you want, you can go for the 0 and play around with it on your own. So we get the fingers, and then we just have to declare some actually media pipe objects. Although right now this might not make sense to you if you are new to OpenCV context, but I just want to import this at this point. And if you are not getting this, then don't worry. When I will use it in a couple of minutes, then I will explain that what's happening over here. So we will refer to this MP media pipe, and we want to import it as MP. So we will go for media pipe, then we want for the solutions, and for the solution we want to get the hands. Just like that from the solutions we need to get the hands. Media pipe, solutions, hands. So we are doing the exact same thing, that from the media pipe we need to get the solutions and we need to get the hands. There are other objects as well, like posture detection, like face detection, but right now we are good with the hands. Now let's just save it inside the variable MP hands. Now this MP hand variable contains all the context, all the or the basic object that will provide us with the context of analyzing our hand video or our hand image. Next is we need to get the hands object out of it. So we will go for MP hands dot hand. Next is this draw. So right now the thing is that when I will just display the image, we can only see the image on the screen, and when we will start processing it, the computer can on its own, this machine can on its own perform it or analyze it perfectly. But for us human, we actually need some sort of visualization to see that what's actually happening over here. So for that we need the MP draw, and we will use MP solutions, and from the solutions we ask for drawing utils. This will help us to draw on the hand. Now again, if all these things are not making sense to you, then don't worry. When in the later, I will explain all of this context when I will start working with that. Now let's just declare a while loop, and For while true, we have to get this cap variable, this capture that we are capturing. Then we have to go for the read. Now what this read will do, this read will simply consider this particular video and provide its each frame or its each image at a time, and we can go on processing on it, and then it will again capture the next image, provide us with that, and so forth. Now here it is providing us with two things. The first one is the variable or the status, that whether we have successfully get the image or not, and then the image. So if we go for the success, hopefully we will be getting it true because it successfully read the image from the video. Otherwise you must be getting this success as false. Now if we go for just printing that, next is to show that we have to go for cv2.imshow. Don't forget to add a title for this. So let's just make it finger counter and the actual image that we want to show. Again, next thing we have to do is we have to put a wait. Now what will happen that if we just simply comment this out and we read the image and we display the image, as it is in while loop, it will go on so fast that our computer will start lagging. So we have to put a wait for 5 key press, that it will wait for a fraction of second, and then it will move further so that our machine get enough time to process that image and display us that image. Now if we give it a go, so we are getting this and this video, and in this video I'm just counting from all the way from 1 to 5. So this is pretty good. Up till here we have done, we have actually read the image and we are printing the image. Next thing is, and also if we go for the status, we are getting the true, the success status. So it means that it successfully read the image. Next thing is we have to convert this image to RGB. So for making it, it's basically a limitation that if you want to make this image processable for the MP media pipe, you must have to convert it in RGB. So right now our image is in BGR format, blue, green and red format, and we just have to change its channel. I'm not going in that much technicality that what's the difference between them and what's the channel and what's all that stuff. But the main thing, and actually you don't really need it right now, you just need to understand that you get the image in particular BGR format and you need to convert it to RGB for making it processable for the media pipe. So we will go for image RGB and we will ask CV2 to CVT color of the image that we are getting from this particular capture. And what we have to do, we have to go for CV2 dot color BGR to RGB. So it will just simply convert the image from BGR to RGB. Then after getting this image, we need to process this image. So we will just go for results. Okay, let's just go for hands. So this hands will now process, and we want it to process this image. Now what this will do, it will simply read this, and if I may just comment this out and show you something over here. So here you can see that there is some difference between the previous image and this image. There is just a slight change between the channel of the colors, and this is the limitation for working with the media pipe library. Now we are taking this hand that contains the hands object, and we are asking it to take this image and process the image and provide us with the hands information. Then we are asking it for providing the, let's just save it in the variable results. Now next thing we have to do, we have to take this results. So it will take the hand, it will take the image, process the hand in the image and provide the results over here. Now from this results, we need to get the multi hand marks. So we will go for results dot multi underscore hand underscore landmarks. Now when I will run this statement, what these two statements will do, this statement will basically take this particular image, extract the hand or locate the hand from the image, and it will pinpoint all the coordinates, all the landmarks available on that hand. Then we are extracting these and we are saving it, let's say, in multi-hand marks in variable. That's it. Now if we just print it, you will notice that we must be getting some sort of abrupt figures and abrupt information, but that basically is representing that where our hand is and what are the basic coordinates of it. So if I just squeeze it out, so here you can see that we are getting this information that we have this landmark and we have these coordinates. So here, this one, and if we just scroll down a bit, so here it is again our list, and for the list we are getting the coordinates for this landmark, which is, let's say for example, we can say that this landmark is basically this one, then this landmark is basically this one, this landmark is basically the coordinates for this one, and so on and so forth, happening for all the points present on my hand. Next thing, after getting the hand marks, we have to check that whether we are getting any hand or not. If I may just remove my hand from the image, this thing will actually become empty. So when this thing will try to process the image, there is no hand available. So how come we can get any landmarks? So eventually it will provide us with the empty results, and then we won't get anything. So the first thing, if we want to further process it, we have to check that if we are getting the hand marks. So if we are getting it, then we will go for iterating on it for hand landmarks in multi-hand landmarks. Now what this statement is doing, this statement is basically providing us with each hand at a time. So if if I may show multiple hands inside this image, this thing will get, let's say, a list, and inside this list there will be some information of coordinates of right hand, let's say, and let's say coordinate of first hand, which we don't go for the right and left here. So we will go for coordinates of first hand and coordinate of second, coordinate of third, coordinate and fourth, and so on and so forth. So that's why we are checking that if we are getting any hand, and if we are getting hand or we are getting more than one hands, we are iterating on each hand. So after iterating, what we are doing, we have to just simply use this draw utility to draw on the identified hand landmarks. So we will go for mpdraw.draw landmarks, and inside that we will provide the image on which we want to draw. Then we will provide the hand LMS or hand landmarks. Then we will go for mp hands, and from here we will ask it for the hand connections because we want it to be connected. Now if I run it, you will notice that okay, so I guess this is, yeah. So here we are displaying the image RGB, and at this point we are portraying it on IMG. So that's why we didn't get actually anything. Now let's just run it again, and hopefully this time we will get the hand and we will get the coordinates on that hand. Now what's happening over here is this thing identified all the hands present inside the image. This thing extracted all the landmarks present on all the hands of the image. Then here we are checking that whether we are getting any hand in the image or not. Then we are iterating on each hand, and for each hand we are asking to draw landmarks on that hand. If we have multiple hands, for the first iteration it will draw on the first hand, then for the next iteration it will draw on the second hand. Now next thing, if at this moment you are still not getting this, then eventually when I will start displaying the coordinates, then this thing will make much more sense to you. Now if I go for IDX and for landmark in enumerate on this hand LMS dot landmark. Now what I'm doing over here, I'm asking it to provide so for this loop, it is providing us for first iteration, it is providing us with the landmarks of the first hand. Then we are asking it to draw some connections and some coordinates, some points on that hand. And actually this is optional step, we can skip it, but still let's just keep it as it is. Then we are iterating over here for this hand LMS, for this hand landmarks, we are getting the landmark and we are iterating on it. Now, if we go for printing the IDX and printing the LM, what will happen? Let me just show you. So just observe. Here we are getting the coordinates for each of the point. So for this point 0, we are getting that for this point 0, at this point, what is x, what is y, what is z. Then we are getting for point 1, that point 1, what is x, y, z, point 2, what is x, y, z, so on and so forth. We are getting coordinates for all the points up till the 20, this one. And then if we go for the 20th, you will notice that next it goes on for the next iteration. As we only have one hand, then it is again providing us the coordinates for the first hand again. So this cycle goes on, and these are the coordinates that it is trying. Next is, here you can notice that these particular coordinates x and y are basically the actual coordinates, and we don't want the coordinates over here. We want to get the image pixels, that from right we want to get to that pixel, from top we want to get to that pixels, and this is the point where we need to just figure it out, that this is the point where our actual landmark is. So for that, it's just a simple formula. So let's just comment this out. And the formula is that we go for img dot shape, and it will provide us with the height and width and color channel of the image. Then we go for extracting the cx and cy, and we ask it for the integer, and we go for lm.x. So we are asking for this lm, this particular lm, let's say for the point 1. For this one, we are asking to get its x coordinate, and we are multiplying it with the width. So now what this statement will do, instead of getting it as 0.4, it will provide us as the pixels from the left. Then for this y, we just need to copy this, put it over here, and instead of x, you got it right, we will go for the w, and we will go for the height. Now if we just print it, you will notice that instead of getting points as these, we will start getting the pixels. So here now we are getting the pixels, and if we just go for IDX, and the reason why I actually converted it into integer is just because I don't want to go for the fractions and all that complexity. So it's nice if we just convert it into integer and make ourselves and cut ourselves a little slack. Now here you can see that for all the points we are getting the information that for point 0, now it's 442 pixels from the x, 442 pixels from the y. Same is for point 1, same is for point 2, and so on and so forth. Next is, now we actually have to save all these points in our array, in our list. The reason for that, I will discuss that reason in a while, but right now let's just do this. So declare an array or a list of hand points, and we need to just save these hand points. And we need to just save this. So what this statement will do, this statement will save all the landmarks available on my hand, and they save its coordinates, they save its pixels, that this point, this 0 landmark is available at these pixels, this point is available at these pixels, and we can do whatever we want to do with them. So I hope that this thing up till here makes sense to you. Next thing is, we just need to simply iterate on the points. So if we go for the point, let me just show you. So if we go for point in hand points, and if I just print the point, now you will notice that for each we are getting the coordinates for each of our landmark. See that this is, let's say this is 0, this is that where our wrist is, this is our point 1 is, this is point 2, this is point 3, so on and so forth. Now just to make sure that we are getting the correct coordinates, let's just draw a circle on it. So we will go for the particular CV2 dot circle. Now for this circle, as we know, the circle, we just need to provide the coordinates on which we want to draw the circle, and these are the points, so we will just put a circle on these points. So we need to get the image on which we need to point, draw the circle, and then the width of the circle, let's say 10. The color of the circle is, let's just make it red, and let's just make it filled. So now if we run it, we are getting the hands, and on these hands we are getting some red dots. If you want, you can actually change the color, and instead of this, you can play around with it and it will just simply change the color for you. So that means that we have successfully identified the hand points and we are successfully actually drawing on that hand. So the actual theme was not to draw on the hand, but the actual idea was that we have to count that how many fingers are open. So for that, we need to actually create an array. Let me just go for the top. Now what I will do, I will declare an array and I will save these points that for the index finger it's 8 and 6, and we have to check that if 8 is less than 6, so that means that this finger is closed. If 12 is less than 10, if the point 12 is below point 10, so that means that this finger is closed. If point 16 is below 14, so that means this finger is closed. If point 20 is below 18, so that means that this finger is closed. And for this one, if point 4 is at the right of point 2, so that means that this hand finger is closed. Now let's just declare the finger coordinates. And here we will go for 8 and 6, then 12 and 10, then 16 and 14, and then 20 and 18. So here we can actually cross check 8 and 6, 12 and 10, 8 and 6, 12 and 10, and 14 and 16 and 14. So 16 and 14 and 20 and 18. Next is the thumb coordinate. So let's just make it thumb coordinate, and for the thumb coordinate we need to save the 4 and 2 because these are the thumb coordinates, 4 and 2. Now so after drawing circles on these points, what we have to do, we have to check that we actually have to save the upcount variable in the variable, and we will check that if a particular hand point is above that, so that means that this hand is open, this finger is open, or otherwise that finger is closed. So we will go for the coordinates. In fingers coordinates, so what it will do for the first iteration, it will provide us with this one, then this one, then this one, then this one. So let's just take the example for this one. So for the coordinates, we must be getting 8 and 6. And now what we have to do, we have to check that if for the hand points that we just extracted containing all the hand points, if for this hand point, we need to get to that particular point. So if we go for this 8, so that means we are asking it for the coordinates of point 8. And if we go for 6, it means that we are asking it for the coordinates of point 6. So this is the basic idea. Now for accessing this 8, we need to go for this coordinate. And for this coordinate, we will go for the 0. Now what this statement will do for the first iteration, this coordinate will be equal to 8 and 6, which is reflecting this index finger. And over here we are asking for the hand points, and this one we are asking it for the hand points for the coordinates of this particular tip of the index finger. Now we need to get to its y coordinate, so we will go for y, because we are checking this y coordinate that this is below this one, this is y axis, so we need to go for the y one. Now we will check that if this one is less than for this one. Now it's just like writing, if this thing is confusing you, it's just like writing this statement. So what we are doing, we are checking that if hand points 8, the coordinates of this point, point's coordinates, then we are asking it for the y coordinate, then its y coordinate. If its y coordinate is less than hand point 6, which is this one, and then its y coordinate. So it is checking that if its y coordinate is less than this y's coordinate, so that means that this finger is open. Now instead of hard coding it for all these, for 8 and 6, for 12 and 10, for 16 and 14, for 20 and 18, I'm just iterating on it and I'm just printing that. So after getting this, we just need to increment the count. So we will go for we will just simply refer to this upcount variable and we increase its value by 1. So if we are in this if, so that means that for that particular finger, that finger is closed. So that means that this finger is open. And now if we just display that, so for displaying it's quite easy. We can actually display the count over here, and if we want we can display the count on the screen as well. So we will go for cv2.text, just like we do the circle on the image, we can put the text as well. So we will go for the image, we will need to go for string and convert this up count to string. Then we have to provide the coordinates on where we need to draw it. So let's just make it 100 and 100. Then the font would be cv2 dot font shape plain. Next is the width, so it will go for 12. Then for the color we will make it 255, 0 and 0. Then for the radius we just need to make it 12, I guess. So if we give it a go, you will notice that it will successfully identify the hand, it will successfully identify the landmarks, and here it is checking on all the fingers. So it is 1. Now as soon as the second finger goes up, it will go 2, and that's perfect. Now let's just make it 150 and 150 so that we can easily see it. And again, just to speed up this stuff, instead of 5 we can go for asking a weight of 1 key press. So we are getting the 4, and now as soon as it's 1. Now it's 2, and it will go on and on. Next thing is we actually have to devise a way for the thumb now, because you might have noticed that it's not providing us with the 5 although our hand was completely open. So we have to put another condition at this level only for maintaining the thumb. So we will go for if the hand points, and for the hand points we will ask for the thumb coordinates. Then we will go for the 0, and we will go for its x, because now we want to check it this way, the x-axis. So we will go for this one for the 0, and we will check it with this one for the coordinate of 1 with the value of 0. We are checking it, and then we just need to up count it by 1. So again, if you are confused, let me just show you that this thing is exactly writing this thing 4 and 2. So we are just putting it like that if we go for 4, this one hand point is basically contains all the coordinates of my hand on the landmarks of my hand, and then I'm asking for the 4th, so it provides me with the coordinates of this point. Then I'm asking it for the 0, so I'm asking it for the x coordinate. Then over here I'm checking it with the 2, and then let me just check, 2. Then we are going for the landmark points of these two, and we are getting its x-axis, and eventually we are checking that if this coordinate is basically greater than this one, so that means that our hand is open, our thumb is open, and we just need to increment the count by 1. Now if we run it, hopefully this will work fine for the thumb as well. So we are getting the 5, and as soon as we close the hand, let me just, okay, I guess 1 is enough. We cannot go for the 0, so let's just run that. So we are getting the 5 fingers. Now we are getting the 1, 2, and actually you might observe there are some glitches over here. The reason for that is just because because of some bad light and because of the poor quality of the camera. There are chances that if you are working in good light with good camera, so you might not get these glitches. Also, it's not only because of the camera and only because of the poor light. This may actually happen because of some lagging in the algorithm, because algorithm keeps on evolving, and there is several reasons that can actually affect this. So don't worry, until unless there is not such as big gap or something like that, we are good with that. So we are getting the 1 finger up and then 0. So this is basically pretty much it. I hope that you develop the understanding of this. I hope that you absorb this, and I would highly recommend you to just get the most out of it, to play around with this, and instead of putting this hard-coded value, try putting the 0, and you will get to play around with this on your own. Also try understanding this code as well, because in the next videos we are actually going to build some cool apps and some cool implementations by using this particular logic, that how many fingers are open. We can go for building some volume control application again, and we can go for some gesture controlling. We just need to put some if-else blocks, check that what are the number of fingers that are open, and then we can go on, and even we can build an application that can be used for the medical help as well, that if a person is lagging some muscular power, or he has something wrong with the muscles, he can actually use this particular application of ours to detect that whether he is successfully opening his all fingers or not, and it can actually communicate that thing back to the doctor. So there is a lot more potential to this, and we will try to explore this in the upcoming video. So I would highly recommend you to absorb this code. Try to write this code on your own, try to get the most out of it, and try to absorb each chunk of it. Still, if you have any questions, you stuck at any point, then we are here for you. Please feel free to let us know in the comment section, and we will try to get back to you on that as soon as possible. Also, please do hit the bell icon and do subscribe to our channel so that you get the notifications of our new videos. This is pretty much it from this video. I hope that you really enjoy it. I will see you in the next one.